In this problem, we need to draw two resonance structure for the diazomethane CH2N2 given the following skeleton. So we need to work it as the Lewis structure. First, we count that in carbon we have 4 valence electron. Okay, in nitrogen we have 5 valence electron. We have 2 of nitrogen, so 5 times 2, and hydrogen has 1 valence electron, 2 of hydrogen. In total, we have 16 valence electrons. Now, start from the skeleton. We simply put the bond between these atoms. That gives us 4 bonds. Okay, 1, 2, 3, 4. Each bond has 2 electrons. Therefore, totally, we have 2 electrons in 4 bonds to electron. We have 8 bonding electrons. Then we have 16 minus 8. We have 8 left. So after that, we work on the terminal atoms. Nitrogen 1, 2, 3, 4, 5, 6. So 8 plus 6, we have 14. So we still have 2 more left. And we put on the central atoms, either carbon or nitrogen. Nitrogen, in some sense, is more central compared to carbon. So this is not general rule, but we just put on somewhere we feel more comfortable. So therefore, we say, okay, let's put the remaining 2 electrons on nitrogen. Now let's check the octet rule. That hydrogen are good, nitrogen here is good, but carbon has only 3 bonds, no lone pair, 6 electrons, which is not good. Nitrogen, we have 2 bonds, give 4 electrons, and 2 lone pairs, 1 lone pair with 2 electrons. Overall, we have 6. It is not good either. So then what do we do now? We know that we want another bond for this carbon, and we think, how about we share these 2 electrons between carbon and nitrogen? Okay, because we cannot add more bond in here, what we can do is we can add 1 bond here. So let's try that. So let's try to delete 2 dot here, and instead we draw a double bond in here. So let's check again. Carbon is good with 4 bonds. Nitrogen only 3 bonds, and nitrogen 3 lone pairs, 1 bond is good, but we need 2 more electrons in here. So we automatically think, oh, why don't we put 2 electrons from this nitrogen and share between them? Okay, now let's do it. Let's delete a lone pair from the terminal nitrogen. Okay, so first we delete everything here, put 6 here, and put 2 lone pair here. And what happens here is a lone pair originally from this position now being shared between 2 nitrogen. Okay, now let's see what we have here. We have a single bond, 2 double bonds around this nitrogen. Okay, and if you look at the carbon, we have 4 bonds here, which is good with octet rule. And if we have this terminal nitrogen, we have 2 electron, 4 electron as lone pairs, and 4 electrons from the 2 bonds. Overall, we have 8 electrons, which is good for octet rule. And for the central nitrogen, we have 2 double bonds here, double bond here. Overall, we have 4 bonds, which give the 8 electron to nitrogen, which is perfect with octet rule. So everything looks good. Now let's look at the formal charges. So the formal charge on hydrogen to be 0, because for nitrogen, for the hydrogen atom, it has 1 valence electron, now have 1 bond, no lone pairs, 1 minus 1 equal to 0. And same thing here for nitrogen, for the hydrogen. And for central carbon, it has 4 bonds without lone pairs. The formal charges for carbon should be 4 valence electrons from neutral carbon atoms minus 4 bonds. No lone pairs is 0. And for the central nitrogen, the formal charges should be 5 valence electrons from neutral nitrogen atoms minus 4 bonds, no lone pairs, it is plus 1. So therefore, formal charges for central nitrogen is plus 1. And the formal charge for terminal nitrogen is 5 valence electrons from neutral nitrogen atoms minus 2 bonds minus 4 valence electron. 2 here, 2 here. No, 4 lone pair electrons. 2 here, 2 here. Therefore, we have negative 1. So therefore, the sum of the formal charges plus 1 minus 1's total is 0, which is agreed with is that this is neutral atoms. Now this is the one of the resonance structure we can come up with, and it turned out is actually the best structure we can have. Also, we have the plus 1 minus 1 on this nitrogens. If you think about this carefully, you will see there's no way we can have 0 formal charges on all of those. How about the other alternatives? What's the other resonance structure? So we start with the 16 valence electrons, and then we add the bond among them. And if you look at this structure, we see, okay, we want to have the carbon and nitrogen agree with the terminal octet rule first. So what we can do, we can think, how about we put 2 electrons on carbon. Okay, let's do that. So if we add 2 lone pairs on carbon, okay, that means we remove this bond and put it in here as the lone pairs. Now after that, for central atoms, for central nitrogen, we need 2 more electrons. Then we say, okay, we can move the 2 lone pairs from terminal nitrogen to share with the nitrogen. Okay, in that way, we will have start with these 2 bonds, double bonds, add another hydrogen, another lone pairs. We ended up with a triple bonds, and we will have only 1 lone pair in the terminal nitrogen we put in here. So you can try, and other ways you find out this is second best resonance structure we can have. Now we look at the lone pairs. We can look at the formal charges. Hydrogen, no change. For carbon, the formal charge is 4 valence electrons from neutral carbon atoms minus 3 bonds and 2 lone pairs, negative 1. Okay, and central nitrogen, 5 minus how many bonds? 4 bonds. It is plus 1. And the terminal nitrogen, 5 minus how many bonds? 3 bonds. And how many lone pair electrons? 2. Give 0 and is 0. And therefore, in this resonance structure, we have negative 1 on carbon, plus 1 on nitrogen, and 0 on nitrogen. Compared to this one, it is not as good as this one. The reason for that is nitrogen has a higher electron negativity than carbon. So therefore, compared to carbon, it's preferred that nitrogen has negative charges. However, in here, we have a negative charge on carbon and plus 1 charge on central nitrogen. So although every atoms are good with octet rule, because of these formal charges, it turned out this resonance structure is not preferred compared to this resonance structure. But this is not bad, because if you try other options, you will find out we cannot have any better resonance structure than these 2 Lewis structure we have here.